The major challenges in HPC for the coming 2 years are two. One is the end of Moore's law, which we will roughly reach by the mid of the 20s. So we still are like 8 years away from them. It will be difficult to increase the performance of systems the way we did it over the last 50 years or so. The second challenge is that we would like to reach the exaflop, which we can only do if we use millions or tens of millions or even hundreds of millions of cores, which will make it extremely difficult to program these systems. So we have one challenge that is a software challenge and one challenge that is a hardware challenge. The vision behind a merger of HPC and global system science is that on the one hand we have a field that has a tremendous need for compute power, and it's only in its beginning when it comes to simulations, while HPC will reach the exaflop in maybe 3 to 4 years from now, which will provide this simulation performance that is required to solve some of the problems of global system science. Now, when we put together HPC and global system science, we face basically two challenges. One is the challenge of finding the right models for describing global systems. This is a thing that was developed over time, but we don't have as much experience as we have with many other applications in HPC simulation. On the other hand, the second challenge is going to be that we need to turn these models into programs that are scalable on millions of cores. Another challenge when we try to bring together HPC and global system science is that we have two different fields that talk two different languages. The global system science people basically come from sociology and comparable fields, sometimes from physics, like in climate simulation or fields like that, but basically it's social sciences. On the other hand, we have HPC, which is a very technical field. People talk about details of hardware, people talk about programming, people talk about mathematical models. So bringing these two different worlds together is another challenge. What is so special about the Center of Excellence for Global System Science is that we target a new challenge. Most of these centers of excellence that we have focus on fields in which HPC is active for decades. We talk about planes, we talk about cars, we talk about materials, we talk about energy. Global system science is a field that has to be developed. So the purpose of the Center of Excellence is not to get another epsilon in the development of the field, but rather to provide or prepare for a quantum leap. For the first time, what we offer is that people who work in global system science actually have access to the fastest systems in the world. That means that it'll take probably longer before we come to solutions. But on the other hand, we will get new solutions provided by HPC.